Okay, so here is our review for Chapter 7. We're going to start with the graphing, and then we have a few word problems. So the first thing up is our graphing. So just go to your calculator, hit the y equals button, and type in 3 times 2 raised to the x power, and then make sure to get out of the exponent and do minus 2. Look at the table, and let's find some good numbers here. So looking at our graph here, we have more negatives than positives. I think with our 5 spots in the box here, just from -2 to +2 is going to be our best bet. -2, -1, 0, 1, 2. And on the test, it's not like there's going to be one correct choice of numbers. Just make sure you pick some numbers that are going to show up on your graph if you can. You can try and stick to whole numbers if you want. Alright, and then, so -2, we've got -1.3. -1 is -0.5. 1, 4, 10. And then let's get those on the graph. So -2, -1, and a little bit. I'm going to zoom way in here, just it's kind of hard to write on the iPad. 1 and a little bit more. And then -1, -0.5, about halfway. 0, 0, 1, 1, 4, 2, 10. So that kind of shoots up pretty quickly. So this starts nice and low and then grows upwards very quickly. And that is our graph for the first one. So down below, I don't know if I'm going to be able to show everything at once here, but we can look at the graph as we answer these questions. State the domain and range. The domain for all of these is going to be all real numbers. The range, so it flattened out right here at -2. I kind of looked at the table and saw that it was getting closer and closer to -2. It also has that -2 on the end of the equation, and that's what tells you where the asymptote is. So y is greater than -2. I noticed they don't have a question about the asymptote. I'm just going to write it just because we have been in all of our notes. And so y equals -2. And then solve the equation when it equals 46. So I'm just looking at the table here, and I see 46 when x equals 4. Alright, there's the first one. So let's take a look at the next one. We've got 2 times 1/4 to the x power. And I like how they did that with the parentheses around the fraction. Just once again, make sure to get out of the exponent before you do the +1. And then looking at the table again, I like the same ones we did before, the -2 to +2. -2, -1, 0, 1, 2. 33, 9, 3, 1.5, and 1.2, or 1.1 actually. There we go. Alright. -233, well that's way off the graph, so I'm not going to be able to graph that one. But -1,9 is right here. 0,3 is right here. 1, 1.5. And 2, 1.1, just a little bit above the line. So, I'm just looking to see where it levels off. It levels off at 1, so I'm just going to have this come down, and then it flattens out right here at 1. And then domain and range. Our domain and range, well, domain we've talked about is all real numbers. Range is y is greater than 1. I am going to write the asymptote again. Y is equal to 1. And then solving the problem down below, look on the table when y equals 33. Well, we actually had that in our table up above. It is -2. Oop. Sorry, I just clicked something I hadn't clicked before. X equals -2. All right, last graphing one. So this is our E. So I don't know if you noticed, but we had one that was growth, one that was decay, and one that is E. So remember the E is on the LN button on the left on your calculator. So 0.8 E -2x, and our table for this one, well, just looking at the graph, it only goes from -1 to 2, or I mean, maybe you could put 3 in there. And let's just stick with what we've been doing. -2, -1, 0, 1, 2. So -2 is 43, so that's going to be way off our graph. -1 is 5.9. 0 is 0.8. 1 is 0.1. And 2 is 0.01. I mean, it's basically 0. Alright, so that -2 is way off the graph. -1 is just below 6. 0 is just below 1. 1 is 0.1. And then 2 is already practically 0. So our line for this one, there we go. Domain is all real numbers. Range is y is greater than 0. And the asymptote is y equals 0. Use your table to approximate the solution. So this one's not going to be as exact as some of the other ones we've seen. But I do see a 2384.8 exactly on my table when x equals -4. Alright, so there are our 3 graphing examples. If you have any other questions, you can come let me know. And then if not, let's just move on to the next page. Alright, so here you have to write 2 problems, any 2 problems that represent growth. So remember, growth is when the base is greater than 1, or for E with a positive exponent. So I think the easiest ones we can think of are 2 to the x or e to the x. So I would like you to write down a different one right now if you can. So don't use my same examples. Question B, that represent decay. This is when the base is less than 1, but still more than 0. So -1 does not count as less than 1 in this situation. I want a fraction like 0.5, a decimal like 0.5, or a fraction like 1/3 to the x. Or we can have an e with a negative exponent. So e to the negative x would be decay. I need to look, and I can look Friday in class, but I'm pretty sure on the test there will be several examples, and you will just circle the growth or circle the decay. You will not have to write them on your own. All right, question 5, our last question already. You have $500 in your account. The account pays 2.75% annual interest compounded monthly. Use the formula given right here to write an exponential growth function that models how much money you have after t years. So we're not going to solve and say how much money we have. We're just going to write the formula by plugging in what we know. So A is just A. P is how much money we have at the beginning. 1 plus the rate. So remember, the rate is not just 2.75. We have to move that decimal over 2 places so that we get 0.0275. And rate, we will never round. I would never say 0.03 in this situation. So 0.0275 over n. N is the number of times we're compounding, so that's going to be 12 for monthly. And then n again is still 12, and then we're just going to put t for time, because we don't know exactly how many years. Down below, now they tell us how many years. So we're going to take our exact same equation and plug in 8 for t. So 0.0275 over 12, and then 12 times 8. All right, so that you can put in your calculator just like it is, not in the y equals part. So 1 plus 0.0275, and then raised to the 12 times 8 power. Yeah, and I got 622.88. Okay, last question here. In approximately how many years will you have $1,050 in your account? So this is where we take our equation from part 1 and put it into the y equals part of the calculator. Then you're going to look at the table. So let me type that in. 500, 1 plus 0.0275 divided by 12, raised to the 12x. So here we don't have a t button in our calculator, so we are going to put x in the calculator. And then go look at the table. And it's going to be a ways down. For your money to double, more than double, is going to take a long time with just 2% interest. So I do not see exactly 1,050, but I do see 1,049.7. So because it says approximately, that is very, very close. So in 27 years, you will earn yourselves a whopping $1,000. All right, that is the whole review here. And so just like this was short, your test on Monday will be pretty short. Let me know if you have any questions, and this might be a good review to watch again over the weekend just to make sure you don't forget anything before Monday. All right, good luck.